Science in pajamas. All right, you guys. So today we're going to talk about free body diagrams. Now, what a free body diagram is it's a simple or simplistic diagram of how to show the forces acting on an object. What I mean by that, let's say we have an example of we have a dog sitting on the floor begging for a treat. So here's our cute little puppers. So there's the puppers. Now, when we draw a free body diagram, we want to kind of not worry about the details and just focus more on the forces. So we know he's sitting on the floor. He's begging for a treat. We know that if he's begging for a treat, he's on the floor, that there's a force of gravity going on. So force of gravity, which will be pulling downward. And according to Newton's third law, for every action, there's an equal and opposite reaction. So that means that we also have what's called the normal force, which is the ground pushing up on the dog. Now, how you do a free body diagram is a lot of times we'll use like a circle or a square to represent our item. So in this case, we're going to talk about the dog. So I'm going to use a dot for the dog. I'll make it a little bit bigger so everyone can see it nice and clear. All right, so we got our dot. We know we have the two forces, and a lot of times, not all the times, but a lot of times, they're going to be balanced out because they're equal and opposite. The arrows that we draw to show the forces, we draw them proportional to their magnitude as well as showing the direction. So the force of gravity is heading downward. F sub g for force of gravity. And the normal force is moving upward. So it's pushing the dog up. Now, notice that these two arrows are about the same size. That's to show that they are equal in magnitude. Let's do another one where it is not equal in magnitude. All right, so let's see. We have a car slamming on the brakes to avoid something in the road. All right, so we have there's a car, vroom vroom, and it's going to slam on the brakes in order to avoid hitting something in the road. So that means that, we're going to have force of gravity, normal force. There's going to be some forward applied force. And we're going to have, we're going to assume friction, so there's going to be some frictional force. And we're also slamming on the brakes, so that means we're actually going to increase that one because of the brakes. Actually, this one should probably be a little bit longer. Now this is more so what a force diagram looks like. When we take that and simplify it down, It's the same idea, it's just one has less detail to allow for us to focus on the arrows. So we have a force diagram on this side. Here's our free body diagram. It shows us what directions the forces are being applied. It shows us an idea of the magnitude because the length of the arrow is proportional to the strength of the force. Let's do a couple more. Let's see. All right. All right, so we have a ball is rolling down a hill. So we have the ball rolling down a hill. There's gravity, normal force. Now, normal is always perpendicular to the ground. Since it's rolling down a hill, the normal force is going to be perpendicular to the hill. The gravitational force is just always down. I say it's going to experience, so it's rolling down a hill, assume friction. It is going to have a frictional one. Now, the reason why we don't necessarily have a forward force is because it's gravity that's pulling it down the hill. Gravity is going straight down. The normal force, notice it's at an angle. So we can actually break that into X and Y components. But we'll talk about that in another video. So that's our force diagram. Let's do the free body. We have force of gravity, force of friction. We have the normal force. All right. We have, let's see. An airplane is flying over a farm. The magnitude of the forces on it are 150 newtons by the earth, 150 newtons by air resistance, 50 by air drag, and 100 newtons applied by its engine. So, again, we'll do the free body or the force diagram first. There's our airplane. So it's 150 from the earth and let's see. Okay. So you have 150 down by gravity. Now air resistance is also what's holding it up. 150 by air resistance. So we have 50 by drag. And then we have 100 applied from the engine. All right, let's take the force diagram, turn it into our free body diagram. We have the dot that represents the plane. We have force of air resistance, force of gravity, and we have the applied force. Notice it's smaller than the gravity and the air resistance, but it is still going to be larger than our drag. Alright, so that's the basics of force diagrams and free body diagrams. I hope that this helps you to understand it, and I will talk to you guys later. Alright, take care. Bye-bye.